a summary introduction of relations and functions, and eventually the parent functions. So what is a relation in X and Y? A set of ordered pairs like X and Y is called a relation in X and Y. Furthermore, the set of first components in the order pairs is called the domain of the relation, and then the set of second components in the ordered pairs is called the range of the relation. By using the definition of a relation, we defined a function. What is a function? Suppose you have a relation in X and Y. We say Y is a function of X if for each element like X in the domain, for sure you can find exactly one value Y in the range. Please note that this means that no two ordered pairs have same first coordinate and different second coordinates. So with this definition, we define different types of functions. Some of basic functions that are very important in algebra, pre-calculus, and calculus are parent functions. The rest of the functions can be derived from parent functions using translations. Please make sure to remember or memorize these functions, their behavior, their properties, and their graphs. This is just a summary for you. The very first one is linear function. The definition of a linear function is f of x equals to mx plus b. As you remember, m is the slope and b is the y-intercept. If m is positive, the line is increasing. If m is negative, the line is decreasing. The domain of a linear function is R or negative infinity to positive infinity. The range is also negative infinity to positive infinity. The range is located on the y-axis. X-intercepts basically are the values that the graph hit the x-axis. Negative b over m and 0 is the x-intercept, and the y-intercept are the values or the points that the graph hit y-axis. So you basically set x equal to 0 and the y-intercept, the y value is b. This function is increasing when m is positive, and it is decreasing when m is negative. So these are the basic behavior of a linear function. The next function that we're interested in is absolute value function. This is a piecewise defined function. F of x is defined as absolute value of x. When x is more than or equal to 0, you get x back, and when x is negative, you get minus x back. So when x is positive, you have increasing line segment or increasing ray, and when x is negative, you get decreasing line segment or decreasing ray. This is the behavior of the absolute value function, and as you see, it is a V-shaped graph. What are the properties for absolute value function? The domain, as you can see, starts from negative infinity and goes to positive infinity. You're basically allowed to plug in any x value into the function. The y values, however, start from 0, goes to positive infinity. So you have half closed interval 0 to infinity. What are the intercepts? Well, the graph hit the x-axis at the origin, also hit y-axis at the origin. It is decreasing on negative infinity to 0. At 0, it doesn't do anything. It is increasing on 0 to positive infinity. This function is an even function. Remember the definition of even function and the test for it. A function like y equals to f of x is even when for each x value in the domain, f of minus x is equal to f of x. It means that the y values are the same for opposite x values. It is symmetric with respect to y-axis. So the graph on the left and on the right, they're basically the same, and they are a reflection with respect to y-axis. The next function is square root function. Square root function is defined as square root of x. The graph of the function, as you remember, behave like this. The minimum x value that you're allowed to plug in is 0. We don't have negative values inside the square root function because you get imaginary numbers. So what are the properties of square root function? The domain, as you can see, starts from 0, goes to positive infinity. What about the range? The range starts from 0, goes to positive infinity. So it happens that the domain and range for this function are the same. What are the intercepts? The x-intercept and y-intercept, they both happen at the origin. This function, as you can see, is increasing function. It's basically increasing on its domain, 0 to infinity, but please pay attention, we are ignoring the initial value or 0 itself. So you use open interval. At 0, it doesn't do anything. The next function that you're interested in, greatest integer function, which is defined as this function takes values on the domain and then it gives you some constant value back. Basically, when you're defining this function, it is the greatest integer that is less than or equal to x. Perfect. What are the properties of this function? The domain, as you can see, starts from negative infinity to positive infinity. You are allowed to plug in any number here. What about the range? The range is the set of integers, right? -3, -2, -1, 0, 1, 2, 3, and so on. So you have integers. X-intercepts, they basically are in the intervals 0 to 1, and 0 is included. So you use half closed, half open interval. This is basically over this interval that you have your x-intercepts. The graph hit x-axis between these values and 0 is included. What about the y-intercept? It only happens at the origin. The only value that hit y-axis is at 0. So as you can see, the function is constant between each pair of consecutive integers. And basically jumps vertically 1 unit at each interval. The next function is quadratic function. The quadratic function in this case is just basically ax squared. The behavior of the graph, if a is positive, the graph opens up, and when a is negative, the graph opens down. What are the properties of this function? The domain starts from negative infinity and goes to positive infinity. You're allowed to plug in any number, any value for x. What about the range? If a is positive, the range starts from 0, goes to positive infinity. So half closed, interval 0 to positive infinity. What if a is negative? If a is negative, the range starts at 0 and goes down. So you have negative infinity to 0, which is included. What about the intercepts? Both of them happens at the origin. So the function is decreasing on negative infinity to 0 when a is positive. And it starts increasing from 0 to positive infinity. What if a is negative? If a is negative, the function is increasing from negative infinity to 0, and it starts decreasing from 0 to positive infinity. This function is an even function. The y values for opposite x values are the same. The axis of symmetry is the y-axis. It has a relative minimum when a is positive, and it has a relative maximum when a is negative. The vertex happen at the origin in either case. The next function is cubic function. F of x is equal to x to power 3. The behavior of the function is like this. The function is increasing all the time. The domain of the function, as you can see, is from negative infinity to positive infinity. The range also from negative infinity to positive infinity. The intercepts are only happening at the origin. The function is increasing on negative infinity to positive infinity. The function keeps going up. It's an odd function. F of minus x is equal to minus f of x. And it has symmetry with respect to the origin. Next function is reciprocal function, which is a rational function. F of x is defined as 1 divided by x. The behavior of the graph is divided up into 2 pieces because of the asymptote. The domain of this function is negative infinity to 0. 0 is not included because this vertical line is vertical asymptote, and it continues from 0 to positive infinity. What about the range of the function? It's the same as the domain, negative infinity to 0, and then 0 to positive infinity, and 0 is not included. There is no intercept. The graph doesn't hit x-axis or y-axis. The function is decreasing on the left-hand side from negative infinity to 0. But take a look at the right-hand side. The graph, when we read the graph, we read it from left to right. The graph starts decreasing as well. So on its domain, the graph is decreasing. This is an odd function. F of minus x is equal to minus f of x. And it is symmetric with respect to the origin. As we mentioned, the vertical asymptote is x equal to 0 for y-axis. It has a horizontal asymptote, which is basically your x-axis. Next function, exponential function. Exponential function defined as f of x equals to a to power x. Remember the behavior of the graph. So when a is more than 1, the graph is increasing. When a is bounded between 0 and 1, the graph is decreasing. The domain of the function is between negative infinity to positive infinity. There is no restriction, plug in values for x. What about the range? Range doesn't include 0. So open interval 0 to infinity. You have one intercept. The graph hit y-axis at 0 and 1. You don't have any x-intercept. You only have y-intercept. The function is increasing if a is more than 1. And the function is decreasing if a is in between 0 and 1. The horizontal asymptote is x-axis. The function is also a continuous function. The next function, which is the inverse of exponential function, is a logarithmic function. This function is defined as log with base a of x when a is more than 1. The graph of the function behaves like this. So for the domain of the function, we are not allowed to plug in negative values for x. It doesn't include 0 as well. So open interval 0 to positive infinity is the domain of this function. What about the range? Well, we don't have any restriction on y values. The y values can be negative, positive, or 0. So range is negative infinity to positive infinity. What are the intercepts? The graph only hit x-axis at the point 1 and 0, but there is no intersection with y-axis. The function is increasing on its interval 0 to infinity, which is basically its domain. It has a vertical asymptote, x equal to 0, or y-axis is the vertical asymptote for this function. And as we mentioned, this is the inverse of exponential function. Our next function is trigonometric function sine function. F of x equals to sine of x. What's the behavior of the graph? The graph is oscillating between negative infinity to positive infinity. It never stops. So the domain of this function is negative infinity to positive infinity. You are allowed to plug in any value into the function and you get y values, but the y values only ranging between -1 to 1 inclusive. The period of this function is 2 pi. After 2 pi, it repeats itself. X-intercepts, it has many x-intercepts. They can be listed as n times pi. So you have a 0, you have 1 pi, -1 pi, 2 pi, -2 pi, and so on. What about the y-intercept? It only hit y-axis at 1 point, 0 and 0. It's an odd function. Sine of negative x is equal to negative sine of x. And it's symmetric with respect to the origin. The next function is cosine function. F of x is equal to cosine of x. The same behavior as we saw for sine happens for cosine. The function oscillating between negative infinity to positive infinity, and it keeps repeating itself. So the domain of the function is negative infinity to positive infinity. The range is between -1 and 1 inclusive. This is the range of this function. The period, the same as sine, is 2 pi. X-intercepts, well, it hits x-axis at -pi/2, pi/2. And n pi plus pi/2, or pi/2 plus n times pi. These are all x-intercepts. Y-intercept only happens at 1 point. When x is equal to 0, your y is 1. It's an even function. F of x is equal to f of minus x, and the axis of symmetry is y-axis. So it's the reflection with respect to y-axis. The next function is tangent function, which is defined as f of x sine x over cosine x, or tangent of x. The behavior of the graph repeats itself from negative infinity to positive infinity, but it has a lot of vertical asymptotes. So what's the domain of this function? The domain is every x value except for pi/2 plus n pi. These are the values that make the denominator equal to 0. What about the range? Well, the range is negative infinity to positive infinity. We don't have any restriction on y values, but we have restrictions on x values. The period of this function is pi. It repeats itself after pi. X-intercepts, well, all of these points that hit the graph and x-axis are x-intercepts. You have pi, you have 0, you have -pi, 2 pi, -pi. These are all x-intercepts, or the values that make sine equal to 0. For a y-intercept, it has 1 y-intercept at the origin. The vertical asymptotes are these dashed lines that make the denominator equal to 0. So basically, whatever you excluded from the domain are your vertical asymptote. X equals to pi over 2 plus n pi are all vertical asymptotes. It's an odd function, and it's symmetric with respect to the origin. Very well. The next function is cosecant function. F of x equals the cosecant of x, which is 1 over sine of x. What's the behavior of the graph? Well, this is the graph of cosecant of x. The domain of this function is all x values that are not n pi. Why is that? Because cosecant is 1 over sine. Sine cannot be equal to 0. So we have to exclude n pi, like 0, pi, negative pi, 2 pi, negative 2 pi, and so on from the domain. Those are basically, as you can see, are your vertical asymptotes. What's the range? Well, if you take a look at the graph, the range is negative infinity to negative 1, union to 1 to positive infinity. So as you can see, there are gaps in between negative 1 and 1. So negative infinity to negative 1, we skip this part, 1 to positive infinity. What's the period of this function? The period of cosecant of x is the same as the period of sine, which is 2 pi. As you can see, the graph never hit x-axis nor y-axis. The vertical asymptotes are the values that you excluded from the domain are vertical lines x equals to n pi. It's an odd function, the same as sine, and it is symmetric with respect to the origin. Okay, what's next? We have secant function. Secant function is 1 over cosine. The behavior of this function, as you can see, is like this. The function is divided up in different pieces. And as you can see, it has vertical asymptotes as cosecant. So what's the domain of this function? Since secant is 1 over cosine, we have to exclude all the values that make the cosine equal to 0. These are the values that make cosine equal to 0. Pi over 2 plus n pi. So we are excluding them from the domain. The range, as you can see, it is negative infinity to negative 1. You have a gap in between negative 1 and 1, and then union 1 to positive infinity. What's the period of this function? The same as cosine, which is 2 pi. What are the y-intercepts? It has one y-intercept at 0 and 1. The vertical asymptotes are these vertical lines that you excluded from the domain. They are x equals to pi over 2 plus n pi. It's an even function, the same as cosine. And the axis of symmetry, the same as cosine, is y-axis.